So what's the private subnet? So whatever instance is in a private subnet that shouldn't have access to internet. So that is the only rule. So when you say you're creating a subnet, you don't say you're creating a private subnet. You create a subnet, and based on the rules which you give to the subnet, you can then define it as a private or a public subnet. So if the subnet doesn't have access to the internet, then it is a private subnet. If the subnet has access to the internet, then it's a public subnet. So the instance in the private subnet shouldn't have a public IP assigned to it. So as I told you last time, when a subnet in a when an instance in a public subnet has access to the internet, even then to SSH to the instance, you need a public IP for it. But in the private subnet, any instance you have, it won't have access to internet. And the other thing is, no instance should have a public IP assigned to it, because yes, we do SSH using public IPs, but still we should not assign any public IP to an instance in private subnet. So okay, the two golden rules: no internet access, no public IP. Well and good. No internet access is okay. So if you don't have a public IP, as I told you last time, did you try SSHing to them? Like, you should have got a network error if you're trying to SSH using the private IPs instead of a public IP. Then in that case, then how do we SSH to a private instance? There should be a way, right? Because you can't just create an instance just for the sake of having an instance in subnet. You should be able to SSH to the instance because you want to deploy your applications or web servers, application servers, do your operations on the instance. So how will we get the access? So there are a few ways actually to get the access to the private subnet, the instances in the private subnet. So okay, now let's say somehow you got the access, you got your you were able to SSH to the private instance. So the next thing, the problem is, you told the subnet shouldn't have access to the internet. Okay, that was the rule. But if you remember the first architecture, we had all our instances in a private subnet. Like, at least one instance would need an internet access, right? Without internet access, many instances, like many applications, can't run. If you're having all your applications in a private subnet, then how will they access the internet? Because at some point they will need to access the internet. So there are few things which we can actually use and which we should be using for that case. So okay, before I get into the NAT gateways, so first thing is that okay, we are not having access to the internet. So is the rule for the private subnet is to not have access to the internet? In that case, is it correct to modify things to get access to the internet? Yes, it's correct. So in a simple scenario, how it is suppose let's say you have a laptop at home. So your laptop has a particular IP address. So when you're actually browsing a site, you don't want to give your laptop's IP address to that particular site. So what do you do in that case? The request from your laptop first goes to the Wi-Fi router, and the Wi-Fi router uses something called a gateway, which masks your IP address and gives it a random IP and sends the request to the browser. So in that case, your laptop is in the private subnet. So you are actually not giving your IP to anyone. You are actually masked. Your IP is masked by a gateway, which is your router in this case, and then you are accessing the internet. So by this, you are actually keeping your instances safe in the private subnet, like your laptop at home. You're keeping it safe. So that is the main thing why we go for a private subnet. Why we have all our applications there? Because we don't want to share our IPs, so that the hackers doesn't get the IPs and they don't try to tinker the IPs. So that is the main reason. So one of the the main thing which we use for the private subnet to get the access to the internet, like the router which I was telling in this example, is the NAT gateway. NAT gateway is nothing but network address translation. So the only job of NAT gateway is to translate the private subnet's private instance IP address into a random IP address and then access the internet. And that's it. It's very simple, because now when you're accessing the internet, you're not giving away your private IP, because the NAT is actually masking the IP address of your instance. So in that case, you can still run your applications in your private subnet, have access to the internet, but you're not directly going to the internet. You're going through the NAT gateway, by which you are safeguarding your IPs, which is not done in the public subnet. That is the main difference between private and public. So actually, if it's theoretical, but let's see architecture here so that you get a good idea on it. So here it is. So here's the instance. This is in a private subnet. Now the instance here needs access to internet. So this instance can't directly access internet because this is in private subnet. So what should it do? It should access a NAT gateway. And remember this, NAT gateway by default is in a public subnet. You wouldn't set it up. When you create a NAT gateway, by default, it is created in a public subnet by AWS. So just keep it, fixed NAT gateway. When somebody asks you where does the NAT gateway is, it is in a public subnet, because NAT gateway is the one which gets the request from the instance in the private subnet, and then it takes in the request and it translates the IP with some randomly generated IP address, and then it accesses the internet. So obviously you would ask me, then how do you know that NAT gateway is in a public subnet? Because NAT gateway is directly accessing the internet. If NAT gateway itself is in a private subnet, then how in the world will it directly access internet? There's no other way, right? So that is the reason they keep the NAT gateway in a public subnet. But if you ask me, do every company follow this? No, like many companies don't follow this, but that's not a good thing. It's always, as I told you, one of the 4 priorities, security is one of them, and securing your applications, moving all your applications to private subnet is a very good thing. The only applications, the only instances which a public subnet should have, only AWS services, you could say in precise, which a public subnet should have is a NAT gateway, and the other thing would be the load balancer. Even if you want to modify, you can modify the load balancer to a private subnet, but that's not really required because you're already securing your applications by putting them in the private subnet. So the only services which you want in the public subnet is NAT gateway and elastic load balancer. Rest all, the database, the databases or the EC2 instances, everything should be in a private subnet. Yes, they can work in a public subnet, but securing is our main priority. That is the reason why we are going for a private subnet on a public subnet. So, okay, now we know how we are going to access internet for an instance in a private subnet. What is the next issue? The next issue which we were discussing is SSHing to a private subnet. So why is an issue? Because we already discussed, because private instance, the instance in the private subnet will not have a public IP. So you don't have a public IP, you're not able to SSH onto the instance. So in that case, there are a few options what we can do, but one of the most and one of the easiest way to do when you're not actually in the production environment, like in a company environment, is you actually create a public instance in the same VPC and you first SSH into the public instance. So let's actually consider the previous architecture. So in the same public subnet, you create one more instance here and you SSH into that instance using the public IP of the instance, and then you can SSH to the private instance by using the private IP. So directly using your PuTTY, you can't SSH using a private IP. To do that, you should first SSH to a public instance in the same VPC, and then you can SSH to the private instance using the private IP. So that is one thing how you can do it. And the second thing is, so if you Google for setting up a proxy servers, there are a few settings how you set up a proxy server. It's like a pretty basic config files. So you can actually set up a proxy server, and that proxy server will have a public IP. And when you SSH to the proxy server using the public IP, you are indirectly in the background, you are SSHing to the private instance. So that is a proxy server, or they call it as a jump server, wherein SSHing to this server, this public server, means you are indirectly SSHing internally into a private server. So this is also similar with the first one. And obviously, this is not a good practice in the company, right? Always you don't want to SSH to one instance to again SSH to a different instance. That is the reason most of the companies use this thing called VPN, virtual private network. So they set up VPNs. If you know, even to SSH to your laptops at home, you use your VPNs. So in the same way, they first switch on their VPNs in the system so that the IP address of the VPN is masked up, and then they can directly SSH to the private subnet. So in the company, in the industry, they use VPN for this whole purpose. For the Amazon service, yes, they do use VPN just for this purpose. If you want to learn more on setting up a VPN and how does this work, you can actually look into Tritonal. Tritonal is also a VPN provider, and it's very easy to get a kickstart, to get a basic structure on how to actually SSH to a private instance without setting up any